Pressure is the ratio of force to the area on which it acts. This is illustrated in the formula pressure equals force over area. This can be demonstrated by looking at this arbitrary pyramid. The force exerted by the pyramid is its mass multiplied by the acceleration of gravity. This will be constant if it's tilted like this, or this, or this, or this. However, the pressure here will be different than the pressure here. This is because the difference in the area of the bases. Force 1 is equal to force 2, and area 1 is greater than area 2. According to the formula, the pressure exerted by pyramid 1 should be less than the pressure exerted by pyramid 2. Static pressure, which is what we're looking at specifically, is simply the pressure of fluids that are at rest. Some examples of fluids that exert static pressure are this tank of hydrogen gas or this tank of water. So what affects static pressure? Let's look at the tank of hydrogen first. For gases, the temperature will affect how much static pressure is exerted. When the temperature of a gas is increased, the molecules will move faster and collide against the sides of the tank with more frequency and with more force. Decreasing the temperature will have the opposite effect. Changing the tank's volume will also affect the pressure. Decreasing the volume of the tank will lead to a higher concentration of molecules. The amount of collisions with the sides of the tank will be greater, which will result in a greater pressure. Increasing the volume will decrease the pressure. Now let's look at the tank of water. For liquids in a tank, the pressure will mainly be affected by whether the top of the tank is open or closed. When the tank is open, the atmosphere will push down on the surface of the liquid. When the tank has a lid, the pressure will be affected by what is contained in the space above the liquid. This area could contain gas with pressure that's higher, lower, or equal to the pressure of the atmosphere. Now what's the difference between gauge pressure and absolute pressure? Gauge pressure is the pressure that's measured in addition to the atmospheric pressure. On the other hand, absolute pressure is the total pressure exerted by the molecules, which can include the atmospheric pressure. The formula absolute pressure equals atmospheric pressure plus gauge pressure illustrates how gauge pressure is measured against the atmosphere while absolute pressure includes the atmosphere. This can be shown again by comparing the two side by side. For example, when the gauge pressure is 0 atmospheres, the absolute pressure is 1 atmosphere, and when the gauge pressure is 2 atmospheres, the absolute pressure is 3 atmospheres. One way to measure pressure is with a manometer. There are 3 types of manometers: open-end, closed-end, and differential. These measure pressure using a fluid in a curve. The pressure is measured by the difference between the heights on either side of the curve. This one is an open-end manometer. This measures gauge pressure. You can tell because since the end is open, the pressure is being measured against atmospheric pressure. This one is a closed-end manometer. This measures absolute pressure. There is a vacuum in this space. Since atmospheric pressure is not being accounted for, this manometer measures absolute pressure. This manometer is a differential manometer. This does not measure gauge or absolute pressure. It simply measures the difference in pressure between this point and this point. Static pressure is everywhere. It pushes the water out of a cooler. It allows us to blow up balloons. It keeps your soda fizzy.